Jumping here from Neural MMO. Every so often we get LLM shenanigans. Alright, that's all the stuff we have to look at for now. So, no, wait, is there one more message? Da-da-da-da-da-da. Okay. Where's that? So, oops, this main gear stuff. I'll give a quick overview of what we were going to do here. We're working on getting the Isaac Gym High Fidelity Physics Simulator bound up to PufferLib. The problem is there are about 3 generations of PhD students worth of terrible code associated with that. So we've been cleaning everything up. We hit tons of driver mesh shenanigans, which took another 6 hours. But I finally got those hopefully fixed. And now we just have to clean up the sim, figure out what's going on, and we should be good to go. I got about, let me think, today I got about 4 hours now and probably another 2 hours after dinner. I got probably 6 hours to get all this stuff done. So I wake up and get to it. Took way longer than I would have liked to get my exercise in and get food and stuff, but went for a pretty hard run and, it takes time to recover. 9:16 pace 5K. After literally 4 days of training, having been in the hospital with pneumonia, so I'll take that anytime, not bad. Okay, so we have our base env, and we have this. Now, I think there is a synchronize, step graphics, draw viewer. I think that there's a synchronize missing, isn't there? Oh. My bad. It's kind of interesting that they bind their docs right to their distributed code. They don't host them. I thought there's a graphics sync function, isn't there? Step graphics. This should be if one is displaying the simulation, this method. Okay, so this is it here. So hang on. If I just put this in here. Put this here, right? Test Isaac. 3.8. Okay, so here we have our bots. They're hovering now. That's interesting. And if I continue, it goes black. The scene goes black. So let's see why. First of all, let's try not doing these actions. Still goes black. Actually, you know what? Maybe there's information we can use in the sim. You know? Unavailable with GPU. So everything goes to Nan. Oops, viewer. I lost a thing. Sim, time step. Worker threads. Okay, so we get all our params in here. But everything is Nan. All Nan. So why is that? I guess the first thing to do would be to see if we can get it to just render, basically. Just update the render. I gotta wake up here. Thought I got mostly enough sleep. And I guess I've been doing a fair bit of work on this lately. Takes a lot out of you. Okay, so there we go. So now, we are no longer breaking stuff. We have everything in this position here. Sim, the viewer, and the perf. Oh, and yeah, you can control this. So yeah, here are all the bots. They're all floating. They've been randomly colored. So actually, they include a pretty nice little renderer for this as well. This is the humanoid. It's got toe flexors and pretty detailed hands, I guess. Yeah, they're pretty darn detailed hands. That's decent, I guess. So, why can't we do anything? If I do this, it breaks, right? Instantly breaks. So self-gym simulate, self.sim. Why does that break it? That's my email. Not leak that. We're just using this to see if there are dots. Basically fuzzy doc search. If your humanoid is initialized, prepare sim is called before stepping, which it is. Sim params. Oh, do we not have DT set? No, we do. It's right here. Solver type 1. Is this? Let's see what happens with this. Tam made it up. That's funny as hell. That's not it. At least on its own, that's not it. I could do refresh tensors maybe. Yeah, I think that's what we do. We go to step up here. And we do this. Oops, actually other way around. Where is it? Oh, man. Actually, maybe I need to do this. Hold on. Okay, so that doesn't help. So we do DOF. This is zeros. This is zeros. All right. This has stuff in it. So we got rigid body state. Zeros. Okay, so this one's a little larger. Okay, so it's all nans. Get gym. What do you think that this function is? Do you think it exists? Or do you think Jippity made it up? I bet you Jippity made it up. Yep. Made it up. Rigid body state is right here. Well, we just checked this. I'm trying to think if the best thing would just be to go line by line with the original. I'm trying to think what stuff I might have changed. It's very difficult to go line by line with the original, though, because the code is so bad. Oops. Okay, so we do set up character props. Which loads the asset. Num obs. Okay. Did we create the ground plane first, surely, right? Okay, so wait, this isn't create sim, which is super.create sim. And this doesn't get called, this gets called by the fucking parent class. Very early. Object-oriented programming needs to be outlawed. This is so horrible. Okay, what do? We do acquire gem. We set a bunch of params. States. Its buffers don't really get used. Create sim, which is where this calls the other implementation. And then prepare sim is down all the way down here. So it's in create sim. And then this calls super. So we set the up axis? I think we do. We set the up axis in the base, right? Yeah. And then we create the sim. So that calls super. Then we create the ground plane, which we just have way simpler here. But we now need to go look for create ground plane. So you make plane params. You make this, and this is fine. And then you have create ems. Gives you square root num ems and spacing. Create ems. I think this is the more complicated one. Do I have all of this? So we have the root here. We get our path. We set these args. And then we load it. And we get the num bodies, rigid count. Yeah. And then we create this force sensor. Spine. Torso index. And then there's a bunch of stuff here they don't use, it looks like. And then they have this loop over num ems, where they call create env. And then they begin aggregate, and then they call build env, and then end aggregate. And then if we look at build env, we have call group, filter, and then we have this transform asset file. Then you call create actor. Then you enable the sensors. And then I actually would prefer to do it like this. We do the color. One per humanoid. And then we do this, drive mode. And then we set the property. And we also append this handle, okay? And then we do the depth of field stuff. We get our limits. We send them to torch. We get their PD, offset, and scale. What do they set for contact bodies? Hold on. I'm gonna set this for now. Contact. I don't think that changes anything. Yeah, no, we're still failing instantly. That is something. You get all these tensors. Root tensor. Root states. Create wrappers. There's apparently a memory thing that you disable. I want to try something. Okay, it's not garbage collection. It's funny that you can do this. I wonder how much faster Python is without garbage collection. Should probably just use C. Oops. Yeah, most languages have like a weird way to mess with their garbage collection system. Welcome back. I am as well. I pretty much just want to finish this and then pass out. That would be the best. Go to sleep at 4 p.m. That would be great. Probably, yeah, about then. So you make all the darn tensors. This is where you make all the tensors. Blank message from Twitch. That's funny. Too much stuff here. Physics step. Actions. Every joint should have a velocity parameter greater than 0. Okay. Acquire is called before refresh. Are you shitting me? That's the one thing I cut out that I thought was redundant. Okay. Dude, that's so stupid. Refresh. That is so stupid. Acquire is called before refresh here. And then, do they refresh? Hold on, they're acquiring it. Okay, so they have it, what looks like they have it backwards. So hold on, this is refresh depth of field, actor root, net contact. So this should just be refresh sim tensors. Before acquire. Hey! Do they fall through the floor? No, they don't fall through the floor. Boom. Look at that. We win. We win. That was so much freaking work to get this stupid thing to like, oh my god. And this is just the basics. Wait, this was just the basics, but still, holy hell. Boink. Here are your robots. I'm gonna commit this. Hold on, I'll answer that in a second. I'm almost finished with my buckshot roulette, and I still haven't played that game. DQN. Would you be able to once over? Yeah, sure, of course. I'll look at the end. You know, if you get it into a gym API, gymnasium API, you can just run PufferLib on it out of the box, and then you'll know whether it's the M or the algorithm that's giving you trouble. Because like we have a nice stable PPO implementation, it's really fast. You can just run it against your environment. It's literally a one-line binding for existing gymnasium environments. Welcome to all the YouTube folks. We just got this thing working. Boom. I thought it was on Steam. Is it online as well? Not playing it on stream, obviously, but they're the robots. Okay. We have robots. Humanoid thingies. I don't do much just yet. Next, we try to get the actions doing something. That works. I would like to rotate them so that they're standing up by default. GPT probably. Transform. Define using a quad. Dude, I love how it just wastes all these tokens and takes forever giving you An annoying code. Okay. Initial pose. So we just have to rotate. This is probably because we have the z-axis up. Or whatever. They're math pi. Lowercase. Need to get the and stop the actions for a second so I can see it. Okay, that's just the wrong direction. It's one of these. It's probably around the Z, isn't it? X, Z, Y, X. So it's this, right? There you go. Perfect. Bonk. Bonk. Cool. Hey, Spencer. Send this to Kyung real quick. Gotta do a little promo here and there. There's a lot of stuff we can do from here. I'd like to perf test this thing. This will be the initial perf. Whoops. So this will be initial perf with only 8 of them. $29 SPS. God. Okay. Let's see if we can't bring that up a little bit. Holy hell. Okay, so it does take numems. And then we do. Okay. And then we would do like, realistically, we're going to have 4096 of these, right? $21,000. So that's unusably bad. We definitely have to bring that up. But we were only getting 10,000 before. So deleting a bunch of wrapper stuff did help, I believe. Is this one of those M's where you really need to crank this to get a perf? Let me see. Let's see if this doubles it. Wait, let me see. If it's low, man, we're just gonna teach you how to do some performance engineering. Like, you're smart enough, you'll pick it up fast. Okay, so it doesn't help above a certain threshold. So we'll use 4096. I mean, being good at writing fast code is very, very, very useful. And often fast code ends up just being simple code as well, which is nice. Occasionally you gotta do some fancy caching, but usually it's not that hard. So there are a few things I want to do here. If I load them all into the same scene on a GPU, yeah. Let's see. I'm gonna kind of use GPT as some docs here. I want to test this just to see. getting about 100. You have to try to make stuff that slow, man. You're in good company, or along with like top RL researchers doing that stuff. But yeah, you're straight trolling. Assuming you mean M speed, not training speed. Yeah, I think we're gonna try this. Well, dude, write a perf test on your environment. It's not that hard. Like, look, do this. It's like 10 lines. And always multiply by number of agents. Because it's agent steps per second. It's multi-agent. It turns out compute clusters completely fucked. They got hacked and are manually pulling files in. Are you kidding me? That freaking sucks. Nation state level attack. Lovely. Can you send them back a Patriot missile as a present? The most valuable of research is the curriculum learning if it solves all of RL. Well, now you got no excuse to not go use your ridiculously expensive university gym because you've got fuck all else to do. No experiments are running. Oh yeah, damn. Go for a run or something, man. Like, I don't know. You can't do shit about that. I did about a 9:16 pace 5K today with 4 days of training since pneumonia. I'll take that. RLC deadline? Yeah, true. I just added a kilometer a day this week from 2 to 5. I think it's the lack of weight. It like, because it feels really easy running, but my heart rate's literally at 185. So, I don't know. It's kind of weird. Usually at 185 I'd be dying, so I don't know. Alright, Zoomer, yeah, yours goes to 205 or whatever. Mine goes to like 190, low 190s, I think. Lighter, yeah, I want to get the mass back though. The rack will arrive in about 2 weeks, and then I get to start doing my stuff again. Oh man, I went down that route in undergrad. I had like 4 monsters a day for most of undergrad. And probably more in alcohol than that. Hey Ryan, check this out. We got Isaac Jim running in Puffer. No, not at the same time. Look at this. Jesus. Gotta get some cardio in, man. Lower that shit. That's ridiculous. Yeah, it's not running. This is flopping around. This is just random actions. Ah, yeah, I remember. Okay, that's rough. It's gotta be something, man. Is there no way around that shit? Because not doing exercise will also kill you. Is there nothing that you can do for that? I think there was some US president who literally like trained himself half to death and like cured his asthma. So that's probably apocryphal. More potent enough. 9 more months. Does it actually cure it after a certain duration of time? Is that how it works? 9 more months of 2.5 years in. Is that how it works? It takes like nearly 3.5 years, but then it's cured. Is that a thing? I don't know how it works. I kind of get what he means though, because like they gave me basically the same thing, and that shit sucks. It instantly spikes your heart rate, but it only spikes it by like 10 or 15. I'm pretty sure. So if it's 98 resting, I think your normal resting is also very high. It's about what mine was before I started doing any exercise. Hmm. I'm gonna try this. It reduces it enough. Oh, okay, that's cool. Yeah, your normal's probably high because you can't do cardio. It's just what it's gonna be. You know? See ya. Best of luck, Ryan. That's some bullshit. I wish I could help you out, but I definitely don't have enough spare puffer boxes at the moment. Once I have the 40, then I will be very happy to support some cool research with you. Ordering those soon, hopefully. Oop. Fortunately, you have to build up your tolerance. Yeesh. That's such bullshit. It's cool that it eventually gets cured, but that's like, fucking hell. Well, you can at least do some powerlifting in the meantime and get plenty jacked. It takes way longer to do strength training than cardio. Like, you know, it's like a couple years for most people. Like, if you have average genetics and you're not like super heavy, it takes like a good 2 years to get a 2-plate bench press. And usually like longer to get like 1,000 total. Took me like 4 for that, though I was also running. Only takes a year to be running marathons from like nothing. So. Jeez. I mean, at least there's stuff you can carry for that. It's not pleasant, but you have it. What are you working on? We're currently working on this high-fidelity physics sim, Isaac Gym. We're getting this bound up to PufferLib, which is my ultra-high-performance reinforcement learning library, and we're cutting out all the dog shit code that's surrounding this thing, so you can actually use it in a way that makes sense. This is what we're currently doing. This stream is pretty much just all the reinforcement learning dev I do. Goal is this year for Puffer to make RL 10 times easier to get working on new problems. I think we will hit that. I'm just sending it random actions for testing. That's no big deal. That's easy to fix. Now the question is, why do I only see one of these? Char, create actor, group. If I do this, I'm still only one of these guys. Enable force sensors. And then you set the color. You set this. I only see one of these guys in the render. Is it faster now? Hold on. Well, actually, that's not going to tell me anything because I don't know if it's actually running these. Did I do something wrong here? College student watching videos for Linux commands and saw the video. Yeah, man, hey, if you're looking to get into some cool RL stuff, We got lots of people. You just need to be able to code. You know, if you can write some code, you can kind of start jamming some RL. Takes people like a month or two to really get onboarded and start writing some cool stuff. It's pretty quick. 600 down to 461, that's good. Less code for same thing is better. Usually, unless you're golfing. Spread out humanoids in a grid. Could that be it? It's literally just they're all on top of each other. Hang on. I'll feel kind of stupid if it's that. It's not that. There should be more of these guys. There's only one humanoid here. Freight actor. 0000, yeah. Oh, wait. You gotta do, I forget. It's a unique. I forgot about that. You're writing in Python? So this wrapper code is in Python. PufferLib itself, which is the main library I developed, the learning and stuff is in Python with PyTorch, but all of the environments, so the majority of the library is in C. So all these environments together are about 20,000 lines of C. And you can play them on puffer.ai, you can watch these agents play, you just hold shift, you can take over for the agent and try to, play for them. Take my hands off, the agent takes over. From very simple to like very, very complex. This is a miniature MMO. I mean, this is a MOBA, something like mini League of Legends or mini Dota. We got lots and lots of stuff on here. This stuff has to be Python though, because it's a library with a Python API, so. I wonder if they do have I don't think they have, I guess technically if it's in C++, we could just not use the Python API. But I think that they have like, I don't know. I'm gonna have to look into that. It doesn't really save anything for the initialization. I don't really want to invest that heavily in this specific framework though. Client is interested in this, a few people are interested in this, but this is not, I don't think IsaacGym is like still fully the dominant platform. I think that there are like a few more now that people are interested in. So it doesn't really make sense to go super, super ham on this. I'm going to get this like, I've cut this from over 2,000 lines down to about 1,000. 2,000 being like the standard wrappers that they provide. So I've made it a lot simpler, but I think digging into this C++ API and like rewriting sections of that is where I draw the line. Okay, so this is still humanoid 0. Oh wait, because this has got to be num actors. Duh. Num actors in. I only deal with networking scripts. I mean, you can do lots of things, right? 390. Gym. Wait, shape. This is num agents, I think. Num agent should be defined. Oh, num actors. vectors. Okay. Oh, wait, there they are. Look at them. So they're all like spread out kind of weird. Right? They're spread out kind of weird. I think that's because of the randomness or the offsets maybe. What if I do this? Whoa! Okay, they're not supposed to collide like that. That's kind of funny though. Bot confetti. Let me see how I get them to not collide. This was in the user guide, but I didn't understand what they were saying. Ah, very nice. A little bit of promo. For folks watching, literally all the stuff I'm working on is free and open source. It's community-led, so you can get involved. You don't have to deal with terrible stuff like this. We're very happy to have people just writing fun M's, and I mean that actually really helps the science side, believe it or not. You can. It's actually pretty quick to learn how to write like really high perf M's like this, and to get into some of the RL. Code's right here. You can start to help us out. Really helps me out a ton. You can join the Discord. This is where we organize everything. And you can follow my X for more content, including some articles on RL. We've got quick start guides for newcomers, all sorts of fun stuff. Don't forget to feed the puffer a star. Back to code. Well, as soon as I figure this API out, that is. Simulation setup. So we have environment collection is pack multiple instances of an environment into a single simulation. Each M has its own coordinate space. It will get arranged in a 2D grid of one row at a time. Oh, so possibly. So I think Isaac Jim potentially does this for you. We'll see about this. Okay, collision group is an integer that identifies the collision group to which they will assign. They'll only collide if they belong to the same collision group. In certain cases, you may wish to set up more than one collision group. It's a bit mask. Two bodies will not collide if their collision filters have a common bit set. Prevent certain kinds of objects in a scene from interacting physically. Collision filter. So I think we look for create actor. And let's see if we get more about the collision filter. Bitwise filter for elements to mask off collision. Maybe, hold on. No will not collide if their collision groups share no common bits. Unique guilt. I don't actually know how this works. Okay, shared collision group. So this is supposed to work. So maybe this does work. Hold on. Do these look like they're colliding, or are they just like... No, these are definitely colliding. Right? These are definitely colliding with each other. I mean, we can double check this very easily. Two. Yeah, see, they all spread out. That means they're getting... So I think that what it would look like... This is what it should look like. This is what it would look like. Yeah, is this what it looks like if there's no collision? Yeah, because they're all like... These are not... There's no collision filter here. You can see that they're all like overlapped. So I don't think I'm understanding the way that the filter works. I don't think GPT is either. Is a bit mask that lets you filter out collisions between bodies. Two bodies will not collide if their collision filters have a common bit set. I think that means this has to be 1. They need to have a common bit set. Does that work? I think that's different, right? Versus, hold on. Versus this. Oh yeah, see how quickly these separate? These separate incredibly quickly, whereas these ones do not. See? They're still like... So I think this works. And I think that what we do now is we test the performance. Now it's possible that this is not any faster. User aggregate size. Huh? I thought you could do that. Can I do 256? $5,000 SPS. Can I do 10.4? And that's slower somehow. I think that I'm barking up the wrong tree here, though, because I think what happens is Isaac Jim actually sticks all the agents in one environment internally. How about this? I can do not that. Okay, that's better. No longer exceeded. User aggregate size. Carb gym plugin. Okay, 28K on 1024. What about this? Okay, that is a lot faster. But we need to test something. Let me think how I want to do this. I think I'm going to very carefully undo all of this, which I just did. Very carefully. Copy it. Redo everything. And then I'm going to do okay, I'm going to do like this. And I'm going to just make some small changes. Yeah. Okay. Environment, new env.py, old env, environment.py. And now we're going to do group will be 0 and filter will be 1 on all of them. Ah. This 74,000, is that substantial? $71. So you get a very small perf boost, it looks like. Let me make sure that that was the case. Environment, old and high. Environment. Okay, it is significant. So I will put a comment here. You get small perf boost 3 to 4%. Putting all so that's nice. We get this. Get axis params. What's the model giving you line complete? Super Maven. I really like it. I have 2 total plugins in NeoVim. One is Super Maven, and the other is Semshi, which just gives you a couple extra syntax highlights in Python. That's all I need. Yeah, everyone has VS Code ones, right? But not everybody has a NeoVim plugin. I don't think Copilot has a nice NeoVim plugin. It's really easy to get this one working, so I like it. It's also very fast. It gives you your code completes very quick. I like it. Okay, 75k steps per second is decent. Now, at least when I got it, it was way better than Copilot for that. I don't know about now. Ah. This next. They cap your amount. You really don't need that for code completion is the thing. Like, you shouldn't be using it for full functions. You should be using it for line completion. And for that, you don't need a crazy model. Honestly, if anybody wants a free startup idea, integrate an LSP properly with code completions. It'll make it way better and way faster. They cap the number of completions you get. Wow. That's annoying. I pay for Super Maven Pro and it's not capped as far as I'm aware. Degrees of freedom. Let's see. Wait, what? We don't need any of that shit. Hold on. Can I just do this? That should be faster, you would think. I guess since there's no self-contact and there's nothing close, it doesn't matter. Mm, friction. Names. Keys? No. How do I get the names for this? Get actor DOF properties. Here, this is how you get the name. The hope here is that by reducing the degrees of freedom here, it should get a lot faster. Okay, so here, yeah, you see this is a lot of degrees of freedom. Thumb, ring, pinky, middle, index. So what we'll do is we'll do this. Thumb. Index, middle. You forgot ring. Oh no. And we take this. What's your plan for this? PPO? Yeah. There's a little bit of extra client stuff on this one. But it's mostly that. Okay, so that's not any faster. Can I see it in the sim? The hand should not be, the fingers should not be flopping. Fingers are still flopping around, it looks like to me. You can't tell. I can't quite tell. It's definitely finding those. You have to set it. Okay, still not seeing any perfing priests. Aggregate. Is rigid. Let me see. Max number of shapes. Flag to enable. So this doesn't exist. Made that shit up. I could comment the joints, but I think then you get I think you just get missing hand if you do that. Double check DMs. Nothing yet. What time is it? Should be 1:30. Okay. So, I don't think this is sufficient. Block joints. See, this is tricky because a lot of the compute right now is just going into the hands, and we do not care about those for this. It's kind of funny that they've got like this relatively blocky humanoid, and then they have the hands fully articulated. Just like, whoa. Is this even working? Remove stiffness, remove damping, disable, and DOF. We should see the hand being like locked. We're not seeing that's not working. It's hard to freaking see, but actually, look. Orientation. Well, it's going to be oriented differently because the whole bot is moving around. Sim. Okay, hang on. Are the fingers moving? We should do 0.05 maybe, or might be too much. Are the individual fingers moving here? Can't tell. It's not moving the wrist either, though. It looks like it could be. Oh, here's an easy way to tell. We can just, does this look different? It's actually very difficult to tell. You see? Stiffness, damping, range. It's a joint. Free joint. Body, joint. Toe is a joint. That's tricky. I don't think we can really mess with this because I think that well, okay. This is a little tricky because we're losing, I think, at least half of the performance to, we're losing at least half of the performance right here to the excessively articulated hands. I do have it running at 7 DK, which is better than before. Much better than before. I think that's going to have to just be the perf optimization I do for now, is just what I've done here. Because I think I got to get like obs and other stuff cleaned up. Yeah. I'm going to take a couple quick minutes, use the restroom, and think about what I'm going to do. And then I'll be back and we will clean up the rest of this, get maybe observations, stuff like that. I'll leave some placeholders for some other stuff, and we will be set. Be right back. Okay, back. One quick thing. There you go. We do good work here. We fix things. This is what we do. Okay, so next, I'm not computing observations yet. I gotta figure out what observations we want. So they do root H obs, local body pause, body rote, body contact buff. They actually have a pretty big observation space. Go check the paper. Go look at this paper. What we're using for observations. States. Consists of the input motions, next pose, along with the difference between the input next pose and the current simulated pose across multiple aspects. Don't give it the current pose. Put it online. Okay, so joint rotation, position, joint velocity, and angular velocity. So the joint rotation, the position, it's got to be of joints, right? Velocity and angular velocity. PD control. Reward function is designed to encourage mimic reward, energy penalty, and adversarial reward. Difference between simulated pose and the input pose. Okay. Energy penalty regulates the policy. Adversarial reward encourages distribution of similar motions. Ah, I see. So that's a little tricky. Okay. But this is not that bad. So these are the only variables. If I get these variables, then we can do whatever. And this is really what you would want. This is joint rotation, position, velocity, angular velocity. So this is all the stuff, and they probably have it already. They probably have this. Local body pause, local body velocity, angular velocity. So I just have to figure this function out. And then they have this crazy reward. But this is from a different paper, right? What I should do is I should check the other paper and see how it's different. And see what they say that this is. Hopefully they tell you what their observations are. State, simulated local position, rotation velocity, and rotational velocity. Does it wait? Local position, rotation velocity, rotation, position, velocity, and angular. So these are the same thing. Local position, rotation, velocity, and rotation. OSS. So they should actually have all the things I need in here. It's just kind of tricky. Body pause, body run, body velocity, and angular velocity. So why is there so much stuff going on here? Local root obs, root height obs, contact forces. So wait. Local body pause, root pause, expand. Okay, I see. So you want to get rid of the global coordinate, which is fine. And then flat local body pause. Flat local. And then they rotate it. I don't know why they do this. So this extracts the root body position, calculates the heading rotation, converts body positions to local coordinates relative to root. There's root position. Joint rotations, linear and angular velocities, joint positions, joint rotations, joint velocities, angular velocities, and contact forces. Root height, I see. So I can just use this, I think. This is a confusing function. But I think I can just use this and get rid of contact forces and root height. Like, this is mostly what I need. Root. If local root ops So this has some extra stuff I don't need, but this is actually kind of fine. Let me see if I can get this to actually run first. Because you do compute. Compute humanoid reward. It's not needed. Wait, where's the freaking humanoid ops? Well, I'm being stupid. There should be compute observations here. Yeah. So this should go here. Compute observation. Compute observations. And this will be we'll figure out what to do from here. Let's just run immediately and give us observations. It looks like it does. We get this and we get observations. Cool. Ops equal ops equals equals point. Here are your humanoids. Ops. Okay, so this is not returning ops. So I didn't return it. One by 778. That's not correct because that's for one agent, I assume. Humanoid ops. Compute humanoid ops max. Humanoid ops. 1 by 788, okay. Compute humanoid ops. Point. Let's see if the tensors going in are correct. Body. Okay, so this is the problem. I don't know why it's by 1. You see, yeah, that's weird. I think the shapes got messed up because I ordered the environments a little bit. It should just be num agents is how it should work. So, yeah, let's sort that out. Because anything else is silly. Oh, are we going to be able to reset individual? I don't think it matters if we can reset individual agents for this, actually, does it? We can anyways. Yeah, we should be able to do that anyways. It's not going to be any worse than resetting an environment. Should be fine. What's this? Root states. What shape did it give you for this? I'm curious. 32 by 13. I have 32 agents, don't I? Yeah, so that's actually freaking perfect. It gives you this in the exact format you'd want. Humanoid root state. So this is just num actors. Yeah, so this is what we call stupid, because this is the same thing. So let's get rid of this. We already have num actors, so we don't need this shit. Initial humanoid root states. We're just going to call initial root states. And then, I don't know why they zero this, but sure. Humanoid actor IDs. Num actors. Should literally just be this now. Actors. So that's easy. DOF state. We don't need this shit anymore. DOF pause. Okay, this is potentially legitimate. Let's see what this is. Trying to get some slices. Self dot. Hmm. They give me a DOF's param thingy. Let me see about this. Okay, that's correct. So I see what they're trying to do here. But then where's this 2 come from? I could get doing yeah, this is a very screwy thing to do. So this should be num actors, DOF per actor. Like this would work, right? No? Hang on. Am I wrong here? Oh, no, because it is of size 2, right? Per actor. DOF state. Ah, okay, so it does have a 2. And then we do DOF view is like this, right? DOF pause. And this ... can just be colon. Num DOF. Num DOF. I don't know about this yet. Num DOF is 153. So I literally just need to, this is just self.numDof. And then it's just self.dof pause is this. Yeah, I think that's it. We do initial DOF pause. And this. We don't really care about the force tensors. And let's see, we got rigid body state here. Bodies per nvis. Probably. They're vastly overcomplicating all of this. Ooh. Rigid body state shape. Num-ems bodies per env. Maybe they're joints, but we'll see. Factors. So it's 16. 52. Thought there were 51 joints. And then this is going to be bodies per env. This is per actor. So this should be num actors. Actor. Let's see how this does. I'm trying to just clean this all up. Num actors, bodies per actor. 32. That's 13. Self rigid body state shape. 30. Okay, so this does actually work out. view. So you get this view. 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 And just colon num bodies. Bodies per vector. Wait, this is still also num bodies. So this is self num bodies. Bodies. And then this is, look how silly these people are. Do you see how silly? You see how it's like everywhere you look, there's just like completely unnecessary complexity for no reason? There should be no contact forces. So I think we can just remove these. Do we need the force tensor? I think we'll keep this for now. We'll keep this one for now. We'll have to fix a couple small things, I'm sure. Probably somebody using those contact forces. I mean, really, like, this is what happens when you just dig into academic code. It's like you just cut it away and cut it away and cut it away, and then there's almost nothing left. And you've just been, like, suffering on a mountain of stupidity of your own creation because you didn't respect the utility of actually writing decent code. That, oh, I can just keep doing science, the code doesn't matter. Yeah, the code matters. It's a very common trap for academics, undervaluing the engineering side. It's really the most useful thing there is. I mean, just being able to build whatever you want and have everything be clear and simple. Well, science isn't taught either, right? You really have to learn that yourself. Like how to actually think scientifically, that takes some number of years of experience, right? But there's, I don't know, it's kind of bizarre. Let me get rid of contact forces. I'm just gonna get rid of these and the body IDs. Hey, bet we've been back, man. This is like hour, I don't know, 6 of the stream, maybe? I don't think we need this at all. Sorry, mate. You're good, dude. You're not obligated to hang on to my stream. Hey, how's it going? I'm getting better. I ran a 9:16 pace 5K today after 4 days of training, since so not terrible. It's gonna take, some number of months to get my old level of fitness back, but at least I can run if I'm careful. I'll be able to start doing compound lifts in a couple of weeks, and we'll see from there. Yeah, I mean I'm gonna have access to some nice equipment, which will be good. I'm ordering a ton of good gym equipment. I'm getting like a very nice power rack. I'm getting a deadlift platform for here. I already have some like okay-ish adjustable dumbbells. So we're gonna get some nice stuff. I'm gonna go from there. And I'm just getting Kyung DMs. So I'll speed up with Isaac Gym. Also Python compiling. That compiles for the whole. So this branch here that I'm working on, I have to check if the Python compiles it. I think it does. It's an old Python version, so I gotta double check some stuff. But yes, for the main like 2.0, that all works. Oh yeah, yeah, yeah. Okay, Tosin, this is you. I forget everybody has freaking different names. Um, yeah, but the thing is, it'll after you compile it once, it'll cache everything, so it'll only compile your robocode. If the full compile works, like you're good because it'll cache everything. So it'll take a couple minutes to compile the first time and then it'll just cache. Just doing a little stuff here, chatting with Kyung on how to get this thing working. Very nice. Uh-oh. So apparently I'm loading the wrong bot. Um, which is actually good news because once I fix it, it'll be way faster. We don't need the stupid finger actuators. Works, right? Yeah, this works. Bonk. Dude, I gotta register to download an XML? No. We'll find it. Okay, it's this dude. I guess I do have to do this. Well, we're fine because we are, I mean, this is open source research. Oh, that's cool. That's nice of them. They added me as an author on GPU Drive. It's fair. I've done a ton of work. Not getting an email from him yet. I'm not getting any emails from them. I thought that this was supposed to be. Where was it? Oh, it went to spam. Didn't I actually get the freaking file? I thought I had the file. Oh, wait, it's this. our hip, torso. They changed. MIT, you just keep your email. Alums just get to keep their emails. It's kind of nice. Stanford, they're like, hey, not for alums. It's like, no, we'd like to have our alums keep their email, which is smart. Ooh, that's weird. Only motor position velocity actuators. Supported. Let's see. No. I deleted garbage. This is a different model as well. We just have to, it just needs some adjusting. And actually, yeah, MIT likes it when you keep, they actually are pretty good about that. Not pinching a couple pennies, clearing email registries. Um, let's see. Yeah, so position control. Don't know. If I do this. That's very weird. Also, it's very weird that it spams this on load. Like it spams it on load is very weird. Asset root. Let me see load. What if I just look for load asset in this repo? No, they don't have load asset. Does this thing use... Oh wait, this is a Majoko based. SMPL. Download models. Models and dependencies. Full data. How does this not have load asset in it? Yeah, it's just GitHub being stupid. Small asset file. Small asset options. Okay, so this is what they set. Block, this is block projectile. We don't want block projectile, we want the humanoid. Okay, here's humanoid asset. Angular damping. Yeah, this is literally everyone copying each other's code. So we got asset root, asset file, asset options. SMPL humanoid XML. I suspect I don't have the right file. Literally spams your whole terminal instantly. Okay, let's see, where... That looks like a different file. Rendered mesh. Automatically create a simple humanoid. Interesting. Is this the same? No, this is a different model. Yes, because it's from Majoko. Oh, this is Majoko too. See if this works real quick. Okay, this might work. It's... How are there more degrees of freedom in this bloody thing? Oh wait, no, I think it was 153 before, or... Hmm. Well, I can check it real quick, right? Oh wait, resources. Yeah, okay. We're good. So, yeah, this is way better. Now, where's the ob space? We're not going to know the observation space, I think, for a bit. To do fix this. Action space is going to be num DOF, I believe. And I guess we'll see rep HY. Oops. Yeah, we don't need this shit. We're not going to know this until we get it from the model, so that's fine. Whoops. And then body contact. So we got key bodies here, and these are going to be different. So let's see if this has a config. Simple humanoid. Okay, this doesn't have. This is simple shape. Do we have the bodies anywhere? Key bodies. I guess I can get this from the task. Key bodies. Config of key bodies. Okay, so it is in a config. We just don't know which config. Yeah. Do you want config control? Key bodies. I think this is simple humanoid here. Whoa. So they fly off. One. Ba-oomph. It's interesting. Interesting. It doesn't seem like well, here, for testing purposes, if we just do 0, They still do that. Well, I think that the action mode is weird. DOF mode, none. Was that what I had it as before? No. If I do this, what happens? They still go crazy. Why? You know what we're gonna do? We'll do this. We will do this. Let me make sure I have the full list. I think there's this reset bodies thing as well. Hang on, I missed something here. So this is all the things in here. So I think if we were to do this, does this change anything? No, it does not. What exactly does CPP change about C to make it worse? It's not that it changes anything specific for RL. It's just that people tend to like just write shittier code. Um, and I don't want to deal with that language. It's just much easier to just write the damn stuff in C. Like I'm just not dealing with people like throwing arbitrary C++ at me and like reviewing and dealing with that. I'm just not doing it. You know, it's very, very easy to write the environments and see the way we're doing it. It's very, very easy to make sure everything is incredibly fast. You know, I mean, we literally have a project I'm supporting that's written in like C++ GPU accelerated game engine. And on GPU, they're getting 50,000 frames per second, and that's after I've optimized the hell out of it. I could write it in about the same amount of code in C and it would run a million. In fact, we're probably going to help import it. Maybe they do this. THC. This isn't here. What do they do differently? You would think it should be in the setup. Jesus, there's so much frickin' code. How do you write 1700 lines of code and then go to sleep saying, yeah, that's a good amount of code to write. That's totally the amount of code that you take to do this. Alright, so we've got this projectile acids. Okay, they're doing something different here. Maybe they do need a little more code. I doubt they need that much more code, though. So tensors. Where's the humanoid? Robot config. I don't know, man. I kind of suspected as much, you know. I didn't think like, yeah, the RL devs in robotics are magically going to be way better than the rest of the field. So yeah, of course they likewise just have a bunch of terrible code. Freaking gosh. Load and set. Create. Okay, so here. Robot config. SMPL robot. Do they have just a ton of parameters you need to load in? This is so slow, they decided to multi-process it. That's hilarious. And kind of sad. Asset real file. asset options. So where you load asset, root, asset file, and asset options. That's it, unless there's anything else they add in here. No, this is all they load in. So how... Is it the force sensors at the feet? Force sensor joints. Force sensor joints here, and it would be left and right ankle otherwise. So I think it's left and right ankle. I'm gonna do L ankle for R ankle. And this is... Does that do anything? Spazzes out and goes insane. Humanoid asset. Drive mode. If I do this. Nope. I don't know what else there is in here that I'm missing. Because this is where you load the asset, right? I wonder if I can benchmark it at least. When this works. I know the sim is pretty heavy. Yep, that's what we expect. $145,000. But I really have no idea what the hell's wrong with this, and I gotta go to dinner soon. I really would like to fix this today. So I can give Kim something stable to deal with. Yeah, this has been a lot. 25 hours in 2 days. Most likely on this. We're pretty close here, honestly. It's just like I loaded in, we had the wrong model, so I loaded in a new model, and I'll show you what happens. It's fast, but it does this. It's less hilarious when you have to fucking debug this horseshit. 145K is nice though. We'll actually be able to train it close to that. I imagine we should get over 100,000 training even with the network, at least for the smallest one. I don't know if Kyung is watching, if you have any idea what's wrong with this thing, but I got no idea. No, you can't just step through it. That's the thing. Because it just goes into some like massive sim. Hold on, this scale is totally weird. Maybe this is it. Let me grab this function just to test. It might be this because the model's different. Okay. And this sets PD. Hold on. We'll undo this garbage code if we fix this. If this fixes it, rather. RPD is, let's see, build PD, and this gets called in right after you load the model. Load. And we do build. Okay. And then, oops, it actually can go right here. So build. PD action. Then we do PD, build PD action, action to PD targets. DOF offsets. DOF. They use those DOF offsets. The heck? DOF names. self.body names. Body names 1 star. Body names. SMPL Joko names. Yeah. Oh my god. Bias offset false. I'm gonna just try this. Dude, what the fuck is this? Like, actually, what is this? Okay. Bumping Neil. I don't know what that is. Doesn't seem to be doing anything. Still, limits don't do anything. I mean, these are all centered on 0. So I don't see how 0 doesn't do anything. I don't think you need this crazy ass PD action scale. Okay. Really? Final scaled actions. That is a good point. Mass. Yeah. It's just not a fun time. I'm just straight up not having a good time with this one. We need that, but we'll see. What do they do with it? They just futz with it a bit. I'm trying to think what it would be. They give me joint limits a while ago. Set DOF drive. I think it made this freaking function up is the problem. I think it loves to make up API shit that just doesn't exist. So what's the function? Stupid fucking thing. So this gets set get DOF properties, and then you can set stiffness and damping. 20 and 0.1. Stiffness, so 0.1. Let's see. Okay. Now, the question is that a good solution or not? So this causes it to fly the hell away. A lot. But there's still weird shit going on. You're not going to enjoy your algorithms course then. Or your advanced algorithms course, at least. The theoretical one. It's okay. I hated that one too. It's just really sensitive. Alright, none of you are flying away now. They fly away at 0.1, really? Yep. Usually taken junior or senior year. You can take it earlier if you want. I took it freshman spring. Not a fun course. I mean, it's perfectly fine if you're anywhere decent at proof-based mathematics, but... $1,200. Really? Oop. Okay, so they just wobble if you do this. If you do... They still fly away? That seems good. And then if I do like 5, then they probably fly away. Oh no, they don't. I think that was it. I have no idea why this is needed in this one and not the other one. But, want to be this? Yes, yes it will. Dude, how stupid do you think I am? Ah, that's stupid. Then we'll hope. A little stupid. A little stupid sometimes. Maybe. Getting rid of stuff we don't need. Anything that's not used gets deleted. Very nice. Okay, 886 lines. And there are a few things we're still going to be able to cut. There we go. 884 lines. Add environment. Alright, get mesh and CPL manually to 140K SPS. Okay, so for folks on YouTube, I will be back after dinner. In the meanwhile, though, if you're interested in ultra high performance reinforcement learning, getting involved in the space, it's easier than you might expect. All my stuff is here on puffer.ai. All the environments right here, we've built all these. They're all ultra fast. You can play them in your browser. You can watch agents play them in your browser. You can hold shift and you can play them yourself. They go from very simple to very complex. Here's a MOBA with economy and trade. Here's a MOBA, an MMO, I mean before. Here's a MOBA like League of Legends or Dota. With nice environments. If you want to see the code, you can help us out a ton. Start the repo, it's free, it really helps. Join the Discord if you want to get involved with dev or use the project. And if you're looking for more content, we have a bunch of articles on the blog here, but there are also some that you can only find on my X account, where I post all sorts of reinforcement learning stuff. Back in a bit. Thanks for tuning in, and see you around.